Good morning, good afternoon, ladies and gentlemen. Welcome to this series of online lessons. If you haven't already, please subscribe to the channel and leave a like for this lesson. Now, in today's lesson, we are looking at Boolean algebra. So we're in Boolean algebra. Okay, and basically, the concepts that we'll get here will help us understand logic gates and how to simplify Boolean expressions. Right. So now one thing you should know is that Boolean algebra actually comes from set theory. Okay, that is from set theory. And these are specific axioms from set theory. So axioms are basic rules. So Boolean algebra comes from axioms of set theory. Axioms, we just mean basic rules. Okay. So now in set theory, we have the following axioms. So if you have a set A and you intersect it with what is outside of the set A, what do you think they used to have in common? So these won't have anything in common. What you get is an empty set. Okay. What about if you get what is in A and union what is outside A? So union means combining what is in A and what is outside of A. When you combine that, you get the universal set. Okay. The second rule that we can talk about is when you get the set A, intersecting it with an empty set. So what does the set A and the empty set have in common? So intersection meaning have in common. So these two will have nothing in common, will give us 0. So they'll have an empty set in common. Okay. So maybe we can also have the set A intersected with the universal set. Okay. So what do you get when you get the set A and you intersect it with the universal set? So you're going to get back the set A. What about the set A union an empty set? So the set A union an empty set, when you combine, union is combining, you're just going to get the set A. Last one, what about the set A union an empty set? Okay, combining the set A and an empty set, what you get there is the set A. Okay, so these are some basic axioms in set theory, and these can be applied to understand axioms in Boolean algebra. So I'm going to say axioms in Boolean algebra. Boolean algebra. Okay. Okay, so the first axiom is okay, or let me say some things that I can talk about even before I talk about the axioms is the universal set in Boolean algebra is represented by 1. Okay, so just think of the where you see 1, think about the universal set, and where you see 0, just think of an empty set. So 0 will be an empty set, and 1 will be the universal set. And what you should also know is that A union B simply is equal to A plus B. So because two events are mutually exclusive, in Boolean algebra, two events are mutually exclusive. So A union B is equal to that. And we have intersection, which is represented by the AND gate. So A intersection B represented by AND. Okay, so that is this is the information that you should have. So the universal set is equals to 1, an empty set is equals to 0. Two events are mutually exclusive. A union B is equals to A plus B. So where we see A plus B, that symbolizes union. And where we see multiplication, it's simply symbolizing intersection. Okay, not to say that the events are independent. Okay, though no, they are not independent, because the occurrence of one event may just affect the occurrence of the other. Okay, now when it comes to axioms, so when you get the set A plus 0, so remember plus means union. Okay, so plus means union. So A plus 0, this is the same thing as A union empty set. What do you get when you combine A and an empty set? You're going to get A. Okay, when you get A and 1, so A plus 1, so this axiom is saying A union universal set. So A and the universal set combined, what are you going to get? You're going to get 1. Okay, so we say that 1 can be thought of as the universal set, and combining what is in A and what is in the universal set also includes A, so we're going to have 1 there. Okay, and when you get what is in A and what is outside of A, okay, when you combine these, what are you going to get? You're going to get the universal set, which is 1. So from here, A union A complement is equals to the universal set. We can also talk about A times 0. So A times 0 is simply A intersection empty set. Okay, A intersection empty set. What do you have in common, A and the empty set? So that is 0. Okay. Then we can also talk about A times A complement. So what does A and A complement have in common? Intersection there. So the intersection of A and what is outside A will give you a 0 as well. All right, so other axioms. So maybe we have A intersection A. So intersecting A and A, what does A and A have in common? So they'll have A in common. So these are some basic axioms. Then maybe A plus A. So that is, what does combining what is in A and what is in A give you? So this will give you the set A. Okay. Then Boolian algebra also has some axioms, or let's say distributive properties. That is, when you have A, then you have B plus C. So this can be written as A, B plus AC. So this is some simple distribution. Same applies to the commutativeness. So if you have A, B, C, like that, so this can be written as A, B, then C outside like that. Okay. So this information is very important because we'll be using it to simplify Boolean expressions. Same applies if you have A plus B plus C. So this way you're starting with this. So you can say A plus B, then plus C outside here. So these are some basic distributive and commutative properties of Boolean expressions. Yeah, and I think one more is because we know that A intersection B is equals to B intersection A. So A plus or A times B is equals to B times A. The same applies for addition. So same applies for addition. So that is A plus B is equals to B plus A. Okay, so yeah, so let's take note of these axioms. Then let's do an example, then we see how we progress from there. All right, so for this example, I'm going to do question 2 and you'll be doing question 1. So for question 2, we have this question here. So what I should also remind you is a complement. Okay, so when you have that bar there, that means complement of something. Okay, so what we know is that we can take out the complement here. So I don't know if I put that axiom there. So that is A. Later, when we have so this is something worth noting. When you have A complement plus B complement, so this is equal to A B complement. So this is coming from De Morgan's theory. That is, you have A in intersection B, or let's say A union B. So if you have A union B, then these are complement. So this basically is equal to taking the complement out. That is A then this becomes intersection, then B, then the complement is out. So this is the same thing. Remember, intersection there means multiplication, and union there means addition. So this is from Morgan's. So that is still applying here. So remember what we said, this comes from set theory. So so here we can take out this, we can take out the complement outside. So let me just use, so we have A, B, C plus. So we have A, then this, we can take out the complement, it becomes B, C, then the complement comes outside like that. And of course, we don't write it like that. So let me just, so we write the complement as that. So we can, meaning that both of these are being applied to the complement like that. So basically you can write it like that, but mostly we use this for complement. So here again, what we can do is we see that A here is common, so we can factor out A. So when we factor out A, we'll remain with B, C plus B, C complement like that. Okay. So now remember what we said. If you have a set A and a set A complement, okay, what does this give you? So getting the set A union, what is outside A? A union, what is outside A? This gives you the universal set. So you're combining what is in A and what is outside A. So this gives you the universal set. So here, let me use a different version here so that you follow the process well. So what we're saying is that if you have the set A plus the complement of the same set, okay, so union means adding. So what is in A plus what is outside of A, what you get is the universal set. So here we have this, so this is the same set, and this is the complement of the same set. So what we're going to have there is this will be equals to A. Then in here we're going to have the universal set, which is basically equal to 1. So we're going to have 1. So 1 universal set intersection. So this is 1 times A times 1. So A intersection times the intersection universal set. So A and the universal set will have in common A, and that is it. Okay, so you apply these axioms to simplify this one, and we'll see how we'll move on from there. Otherwise, see you in the next lesson, where now we'll go to logic gates. Or maybe even before we go to logic gates, let me just illustrate to you how this information can help us solve logic circuits. So maybe we know that there are two circuits. There is this is called the AND gate, and this is called the OR gate. Okay, so AND there, AND is simply intersection. So if this is 0 and this is let's say we have B, that is 1. So this is just taking the operation A0 and which is intersection B1. Okay, so now this will have an input or an output here. So maybe let's say this an output. Then there is also the NOT gate. So NOT gate simply means complement. Okay, so this is complement. So whatever is coming in here, complement, meaning that not that. Okay, so for instance, if this is a 1 and a 0, and we take them through an AND gate, so 0 intersection 1. Okay, so that is an empty set intersection the universal set. So what does an empty set intersected with the universal set going to give you? So it will give you an empty set. Okay, so they'll have an empty set, it will give you 0. So meaning that the product here, or what will come out here, is this part. So A0. So A0 will come out here in the AND. Okay, so now if you have A0 here, you have complement. Complement is outside of A. So outside of A, that is will be 1. So what will be out here will be 1, which is a B. Okay, so this will basically be a B. not A. So not A. So not A0. So what is not A0 is simply B. So basically having this understanding will help you with solving logic circuits. So now in the OR gate, this is union. Okay, union. So if you have A there and you have B, so let's say again your values 0 and 1. So union. So this is A1 union B0. So this is the same thing as 1 is being represented by the universal set union an empty set. So 0 is an empty set. So what do you get when you combine the universal set and an empty set? You're going to get the universal set. So you're going to get A1 as your product here. Okay. So this is just an idea on how you will be able to work out logic circuits, but we'll look at it in detail in the next one. Otherwise, have a great evening.